The ramp theory, a comprehensive analysis of pyramid construction. The construction of the Great Pyramids of Giza has puzzled humanity for centuries, sparking numerous theories about how the ancient Egyptians managed to build such monumental structures. Among these, the ramp theory stands as one of the most widely accepted explanations. This theory posits that massive ramps were utilized to transport limestone and granite blocks, some weighing several tons, to the desired heights during pyramid construction. However, the exact design and implementation of these ramps have been the subject of extensive debate and analysis. This article explores the various ramp configurations proposed, their feasibility, challenges, and the evidence supporting this cornerstone of ancient engineering ingenuity. The mechanics of the ramp theory. The ramp theory suggests that ramps were used to move the massive stone blocks into position during the construction of the pyramids. To achieve this, the Egyptians would have required a sophisticated understanding of geometry, physics, and workforce organization. The ramps, likely constructed from mud brick, limestone chippings, and clay, served as pathways for hauling stones using sledges and manpower. Different variations of ramp designs have been proposed. 1. Straight ramps. A straight ramp extending from the base to the construction site on the pyramid's upper levels is one of the simplest proposed designs. This ramp would have been aligned with one of the pyramid's sides, allowing workers to transport blocks to progressively higher levels. Advantages. Simplicity in design and construction. Istal said. Direct access to the work site. Challenges. Enormous length and volume of material required to achieve the necessary gradient. The difficulty in maintaining structural integrity over such a long distance. For example, to reach the top of the Great Pyramid, a straight ramp with a manageable gradient of 110 would need to be over a kilometer long, requiring vast amounts of materials and space. 2. Zigzagging ramps. Zigzagging ramps, also known as switchback ramps, involve a series of shorter ramps that zigzag up the pyramid's face. Workers would haul stones up one ramp, then turn to the next, gradually ascending the structure. Advantages. Reduced material requirements compared to a straight ramp. Less space needed around the pyramid. Challenges. Turning stones at each zigzag junction would have been cumbersome. Complexities in engineering stable corners and transitions. The other agent nodded. All right. Okay. The tunnel ended into a crest, a downward dramatic crest, slowly. The other agent nodded in confirmative. 3. Spiral ramps. Spiral ramps encircling the pyramid as it grew in height offer another plausible solution. These ramps would have wrapped around the pyramid's exterior, allowing stones to be transported continuously upward. End of section 17. Recording by Michael Foss. Advantages. Consistent access to all sides of the pyramid. Challenges. Structural instability, particularly at higher levels. Nick. Potential obstruction of construction work on the pyramid's faces. Some proponents of the spiral ramp theory suggest that ramps might have been constructed within the pyramid itself, hidden from view. This internal ramp theory is discussed later in this analysis. Evidence supporting the ramp theory. Several lines of evidence lend credibility to the ramp theory, including ancient texts, archaeological findings, and experimental reconstructions. Historical records. Ancient Egyptian inscriptions and reliefs depict workers hauling large statues and stones using sledges on prepared pathways. One of the most notable examples is the transportation of a massive statue of Jehuti-Hotep, which illustrates teams of workers pulling a sand to reduce friction. All of a sudden, some thirsty snake comes out, brandishes swirling in the air. Who knows what will happen to it, then falls into the sea from grief. Archaeological discoveries. Archaeological evidence near pyramid sites includes remnants of ramps and tools that support the theory. For instance, at the Pyramid of Khufu, remains of inclined ramps with wooden sledges have been discovered. In 2018, archaeologists unearthed a sloping ramp system at the Hatanub quarry, used to extract alabaster blocks. This system employed a central staircase flanked by inclined planes, demonstrating the Egyptians' ability to move heavy stones uphill. Experimental studies. Modern experiments have replicated the use of sledges on inclined ramps. For example, a Dutch team demonstrated that wetting sand significantly reduces friction, making it easier to transport heavy loads. Such studies validate the feasibility of moving multi-ton blocks using simple tools and manpower. Challenges and criticisms. While the ramp theory is widely accepted, it is not without its critics. Some of the challenges include material requirements. The sheer volume of materials needed to construct ramps capable of reaching the pyramid's upper levels poses logistical questions. How were these materials sourced, transported, and later removed without leaving significant traces? Labor and coordination. The theory implies an enormous workforce, tens of thousands of laborers, working in harmony. Organizing such a workforce, ensuring their welfare, and coordinating tasks over decades would have required extraordinary administrative skills. This is a big one. It works, with no skill at all. Structural limitations. For ramps extending to great heights, maintaining structural integrity and preventing collapse would have been a formidable challenge. Engineers would have needed to continuously modify the ramp design as the pyramid rose, adding to the complexity. That's when constructors understood, for a tower that high, to stay on target, a ramp still needed to remain solid, bulky, and more than 2 meters thick. The internal ramp theory. French architect Jean-Pierre Houdin proposed a variation of the ramp theory that addresses some of its shortcomings. According to Houdin, internal spiral ramps were constructed within the pyramid's core. These ramps allowed workers to transport blocks upward without the need for extensive external structures. Advantages. Reduced material requirements compared to external ramps. Protection from weather and external erosion. Challenges. Difficulty in constructing such ramps within the pyramid's tight confines. Modern imaging technologies, such as muon tomography, have provided intriguing hints of voids within the Great Pyramid that could support this theory, though definitive proof remains elusive. Alternative theories. While the ramp theory dominates scholarly discourse, alternative explanations for pyramid construction exist, including the use of levers, pulleys, and advanced ancient technologies. Some even propose extraterrestrial involvement, though these ideas lack empirical support. I am the God. So put is man to the test of scientists at several points, and all changed their minds. Cultural and technological context. The use of ramps reflects not just a technical solution, but also a cultural and logistical achievement of ancient Egypt. The construction of such large-scale ramps would have required centralized planning, resource management, and an understanding of the physics involved in moving heavy loads. This capability showcases the sophistication of Egyptian engineering and their societal organization, which made such monumental projects possible. This meant that gods, or the elements, might have been in the sky on numerous occasions, visiting Earth to trade their contrast and transcendence, albeit with a massive assembly. Religious significance of construction techniques. The construction of pyramids was deeply intertwined with Egyptian religious beliefs. The ramps, by extension, were not merely tools, but part of a sacred endeavor to honor the pharaoh and ensure their journey to the afterlife. Every stone laid through these methods contributed to a structure that was as much a spiritual artifact as it was a physical one. The ramps, by extension, were not merely tools, but part of a sacred endeavor to honor the pharaoh and ensure their journey to the afterlife. Conclusion: the ramp theory's enduring legacy. The ramp theory remains one of the most plausible explanations for how the ancient Egyptians constructed their awe-inspiring pyramids. While challenges and questions persist, the theory aligns with known historical practices, archaeological evidence, and experimental studies. Whether through straight, zigzagging, spiral, or internal ramps, the ingenuity and determination of the ancient Egyptians shine through. Their achievements continue to inspire and challenge modern understanding, reminding us of the incredible capabilities of human creativity and cooperation. Future research and technological advancements may provide more clarity, but the ramp theory, in its various forms, remains a cornerstone in our understanding of ancient Egyptian engineering. It is a testament to a civilization that harnessed the tools and knowledge of its time to achieve what seemed impossible, leaving behind one of the greatest architectural legacies in human history.